This section is about solving rational equations. Okay. Now, think about rational equations is they have denominators. Now, for example, let's solve 12 over x is equal to 3. Now, the unknown is in the denominator. To get the unknown out of the denominator, multiply by it. So we're going to multiply both sides of this equation by x. All right, and after cancellation, we get 12 is equal to 3x, and by dividing by 3, we get x equals to 4. Fairly straightforward, but we have to think about something called excluded values in these problems. And that is, an excluded value is a value of x that would make the denominator 0. And in this case, since the original equation was 12 over x, that means x equals 0 would be is an excluded value. X cannot be 0. However, the solution to this is x equals 4. So that is not an excluded value, so that makes x equals 4 a valid solution. All right. Let's solve this one. Now the denominator is x minus 4. So let's multiply by it. So we're going to multiply both sides by x minus 4. On the left-hand side, it cancels out. And what we're left with is 4x plus 9 on the left side and 6 times the quantity x minus 4 on the right side. Now, we want to first distribute the 6. All right. And then I just have to go through the business of algebra to isolate x. So I'm going to subtract 4x from each side, and then I'm going to add 24 to each side, and then I'm going to divide by 2. And so the solution is x equals 33 halves, okay? As long as it's not an excluded value. Now, the excluded value would be the value of x that would make this denominator x minus 4 0 would be x equals 4, okay? But since our 33 halves is not 4, that makes 33 halves a valid solution. Okay, next example. Now we have a minus 5 in the denominator, so we're going to multiply by it. And on the right-hand side, it cancels out. And on the left-hand side, we distribute the 3 to get 3a minus 15 equals 4a squared plus 12a minus 10. Now we want to set this equation equal to 0, so I'm going to eliminate stuff from one of the sides. I'm going to actually eliminate this stuff. So I'm going to subtract 3a, and I'm going to add 15 to both sides. And we're left with this after I turn it around, 4a squared plus 9a plus 5 equals 0, which we now have to factor. So my method of factoring is I take factors of 4, 1, 4, 2, and 2, put that left-hand column, factors of positive 5, in the right column, and I look for combinations that'll give me a positive 9 sum, which I find right here. That is 4 times 1 is 4, 1 times 5 is 5, and they add to 9. So that is my winning pair. So now I have a and 4a, all right, and the 1 is paired with the 5, and they're never in the same set of parentheses. That makes a 5 go in that set, and then the positive 1 is paired with the 4, so that goes over here. And now we're going to separate and solve as per usual. And here I'm going to subtract 1 from each side to get negative 1. And over here I'm going to subtract 5 and then divide by 4 to get a is equal to negative 5 fourths. Now our excluded value, the value of a that would make this denominator 0, is a equals 5. That's neither of the ones we solved for, so we don't have to throw any of them away. We can keep them both, and those are our answers. Okay, let's do this example now, and this is a little bit different because we have an x in the denominator here, and we have an x minus 3 in the denominator there. All right, so a little bit different. The way to eliminate the denominators, we're going to multiply by the least common denominator, which in this case is x times the quantity x minus 3. Okay, so let's multiply that on each side. On the left-hand side, we have to more or less distribute this throughout these brackets. So this times the first term, the x's cancel out, and we'll be left with x minus 3. In the second term, the x minus 3's will cancel out, and they'll just be left with x. And on the right-hand side, the x minus 3's will cancel out, and I'll be left with x times the quantity x minus 2. Okay, so take a moment and make sure that you understand that. The first term, the x's get canceled out. In this term, the x minus 3's get canceled out, okay, yielding just x. Then over here, x minus 3 cancels out x minus 3. What's left over? X times the quantity x minus 2. All right, now simplifying this, x minus 3 plus x, combining like terms, we get 2x minus 3. And then distributing the x on the right-hand side, we get x squared minus 2x. Now, setting this equation equal to 0, again, I'm going to take the left-hand side. I like to have the x squared term to have a positive leading coefficient. So I'm going to get rid of this stuff by subtracting the 2x and adding 3. And when I do that, the left side equals 0, the right side equals x squared minus 4x plus 3. And now we go through the business of factoring that, and I get quantity x minus 3 times quantity x minus 1. Okay. And now we're going to separate and solve. So x minus 3 is equal to 0, yields an answer of x equals 3. X minus 1 equals 0, yields an answer of x equals 1. Now, what are the excluded values in this case? What values of x make the denominators in the original expression 0? Well, x equals 0 is 1, and x equals 3 is another. Notice that one of our solutions is an excluded value. So we just throw it away. And so our answer is x equals 1. Okay, now, what would you multiply by so that each denominator will cancel out? Pause this for a moment and come up with the least common denominator. All right, the denominator that will do that is 4y. Now, it actually, that's not, of course, the only thing that will cancel everything out. It's just the least common denominator. If you were thinking 8y, multiply everything by 8y, that'll work too. Okay, so anything that will cancel out all the denominators. We'll end up with the same answer in the end. But I'm going to multiply by 4y. On the left-hand side, the 4y's get canceled out, top and bottom, and I'm just left with y minus 3. Over here, for the first term, the 4's cancel out, just leaving y. In the second term, the y's cancel, the 4 cancels out the 2, leaving a 2 in the numerator. Okay. And what we get is 2 times the quantity y plus 2. So the first term is y minus 3 equals just y plus 2 times the quantity y plus 2. Now simplifying, we're going to distribute the 2 through the parentheses on the right-hand side. Then we're going to combine like terms to get 3y plus 4 on the right. And then we're going to go through this business of isolating y. It's not a quadratic here, so just the simple rules of algebra will get us there. So I'm just going to add 3 both sides. Okay, subtract 3y to get the y's on the other side. And then divide out by the negative 2, and I will get y equals negative 7/2. The excluded values for this, what value of y will make the denominator 0? Well, just y equals 0. And so y equals negative 7/2 is our answer there. All right, what about this one? Well, what we need to do before we multiply by the equation by anything is just factor each denominator. I need it down to its basic factors. So I'm going to factor the 3w squared minus 3w minus 18. And the first thing I notice is 3 is a factor of each term, so I'm going to factor out the 3 first. I get w squared minus w minus 6, which can factor down to quantity w minus 3 times the quantity w plus 2. Okay? All right, that's this denominator factored and this denominator factored. And then this denominator factored, I can just factor out a 3, and I get 3 times w plus 2. So the we can rewrite this example to look like this. Now, what are we going to multiply this thing by so that all the denominators cancel out? And if you think about it for a while, hopefully you can see that that denominator will be 3 times the quantity w minus 3 times the quantity w plus 2. So let's multiply by that. And in the first, if you look at just the first term, this entire thing cancels out this entire thing, just leaving the 1. Okay. In the second term, this entire thing cancels out this entire thing, leaving the w minus 2. Careful to put that in parentheses. And on the right-hand side, the 3 gets canceled out, the w2 plus 2 gets canceled out, leaving only w minus 3. Okay. Take a moment and make sure you agree with that. All right, now we got to solve this for w. I don't have to factor because it's not a quadratic. That's good. So I have to distribute the phantom negative 1 through that set of parentheses, so I get 1 minus w plus 2. Okay, combine like terms. All right. Let's see what I'm going to do. I want to add w to both sides. Okay, and I'm going to add 3 to both sides. Then divide out to 2. And I get w is equal to 3. Okay. All right. Now, I'm going to say, okay, what is going to make the denominator 0? What are the excluded values? Well, the excluded values are going to be negative 2 and 3. Notice that 3 is one of those solutions, so we throw it away. What solution is left? Nothing. So the answer is no solution. Okay, next. What am I going to multiply both sides? What is the least common denominator of this expression, or what is a common denominator? Well, yeah, okay. What is the least common denominator? Pause. Try to figure it out. Well, the least common multiple of 2 and 3 are 6, okay? And the least common multiple of p and p squared is p squared. So that means the least common denominator, least common multiple of all those terms is 6p squared. So that's what I'm going to multiply by. On the first term, we multiply 6p squared times 5/3. Okay, 6 times 5 is 30, over 3 is 10. So it's going to be 10p squared. That's going to be the first term. The second term, one of the p's cancels out. 6 and 2 cancel out to 3, so I'm left with 3p. And on the right-hand side, 6p squared cancels to 6p squared, and I'm just left with 1. All right, subtract 1 to set this equation equal to 0, and factor. And so I have factors 1 and 10 and 2 and 5. And factors of negative 1 are 1, negative 1, and I want a combination to get positive 3, which I can find by pairing it this way, because 5 times 1 is 5, 2 times negative 1 is negative 2, and those add to 3. So that's my winning pair right there. So this is going to be 2p and 5p. The 2 gets paired with the negative 1, so that's over here. The 5 gets paired with the positive 1, so that's over here. So however you factor, we should get to this point. Okay, now we separate and we solve. Subtract 1, divide out to 2, and I get p is equal to negative 1/2. Add the 1, divide out to 5, and I get p is equal to negative 1/5. And then what are the excluded values? The excluded values are, that's just p equals 0. Okay, that's going to make the denominator 0. Neither of our solutions are 0, so we keep them both, and so those are our solutions. Okay, one more example to do. This one right here. Now I need to factor this denominator. So I'm going to factor that denominator. And when I do that, I get quantity b minus 6 times the quantity b minus 2. And so that's what I'm going to multiply this expression by, both sides. Okay, now on the left-hand side, in the first term, the b minus 6's cancel out, leaving only b minus 2. Plus, in the second term, the b minus 2's cancel, leaving only the b minus 6 times the b. So the left-hand side is going to be the first one. B minus 6 cancels out to get b minus 2. That's where that comes from. Plus b, and then the b minus 2's cancel out, leaving only the b minus 6. And on the right-hand side, this cancels out that entirely, leaving 4. Okay, so take a moment, make sure that looks right to you, or be sure to ask me about it. Okay, so that you got to get to this step. That can be tricky. Okay, now we need to simplify this. So that's just b minus 2. Distribute the b through there, and we get b squared minus 6b equals 4. Combine like terms. Set it equal to 0. And then factor it. And this factors to quantity b minus 6 times the quantity b plus 1 equals 0. Which we then separate and solve. So b minus 6 equals 0 yields an answer of b equals 6. B plus 1 equals 0 yields an answer of b equals negative 1. Then we check out our excluded values, and our excluded values are 2 and 6. 2 and 6, which means that this solution up here is excluded, so we throw it away, and the only answer is b equals -1. And that's solving rational equations. Okay, the key is to get rid of the denominators because denominators are tricky, they're annoying, and the way to get rid of them is to multiply by something that will cancel all of them out, which turns out to be the least common denominator. From then on, we use basic stuff, factoring, combining like terms, all that kind of stuff. Pay attention to the excluded values because they will render some of the solutions extraneous. Okay. All right. Time to practice the practice problems.